Hello everyone, welcome back to the channel. Today we are going to discuss a very complex yet very important topic. We almost uh, every day use it, right? For when we use the banking application, so our any secure application like we use HTTPS. We hear this term each and every time. So how this HTTPS works, or basically your TLS works, or how this encryption, so how this encryption over the network or encryption in transit or in flight, how does it work? So let's understand that. So first of all, I'm going to discuss the previous version, which is your TLS 1.2, which was the RSA key exchange, and then I'll discuss the latest version, which is TLS 1.3. So you will understand the difference as well in why TLS 1.3 was introduced and why this upgrade happened. Okay, so let's start. Okay, so when you type HTTPS, say like I do like HTTPS hdfcbank.com. So what happens basically? Okay, from client to server. So the first part is simple TCP connection that will happen. So it is just like establishing a TCP connection. It's a three-way handshake that will happen. Sync, then sync acknowledge by the server, and then client will also acknowledge. And here the TCP connection is established between the client and the server. Now comes the next part, which is TLS handshake, which is your exchange and authentication. So what client will do is client will send hello, basically kind of a random text, okay, or a random number or something. So random string you could say, or hex code. So client will send that to server. So this is called as client random. This is very important. Just keep this in mind because this is going to be used later on. Then server is also going to send the server random, something random number, which is generated by the server and client is aware of it. So now both client and server are aware of the client random and the server random. Just keep that thing in mind. Now what happens? Server is also send its server certificate, right? So you know that when we use this HTTPS etc. We have to yeah, I mean the X.509 server certificate, right? So you have to go to some authority like it could be like Amazon etc. And then you can actually create your server certificate, and that will be used for your TLS exchange or your secure network or your secure communication. So now server will send its certificate. Okay. Now server will send its server certificate. What client will do now is it will obviously there will be some verification process which that will happen. So what this verification process is basically it will check whether this is from the trusted domain or whether this certificate is valid or not, etc. And from this certificate you get a key. Okay, you get a public key. So just keep that in mind. So this server certificate will have what a public key of the server, which is now client is also aware of it. So what client will do next is it will generate some pre-master secret. Okay, you could say that some secret key which is generated by client. What it will do is it will encrypt it using this public key. So it will encrypt it using this public key. So now your pre-master secret key is now encrypted in the encrypted form, and this encrypted pre-master secret will be sent to server. Okay, and server, because it was encrypted using the public key, right? It was encrypted using the public key. So server is able to decrypt it using its private key. Okay, so if you are aware of the asymmetric encryption, right? Asymmetric encryption works on two keys. One is the public key and the private key. So I will do the encryption using the public key, and the server will do the, or basically the decryption happens using the private key. So server has the private key. Private key is never shared. It will always be with the server, and public key is available via the certificate. So client will actually do the encryption. Now encryption is done of what? Of the pre-master secret. So now this is your TLS handshake, which is the second phase. I'm just repeating again. So what did we do in the second phase? We shared the random client random and server random with each other. We got the server certificate, and with using this server certificate, after validating it, we extracted the public key of server, and then we also client also generated pre-master secret key. Okay, encrypted it using the public key and send it to the server, and server was able to derive or decrypt or get the pre-master secret using the private key. So here private pre-master secret is known to both client and server. Just keep this thing in mind. Okay, this pre-master secret is now known to both client and server after the end of this phase. Now let's move ahead. Now what will happen? Key derivation. Now this is locally on both the sides. Okay, there is no communication that will happen between client and server using this pre-master secret key, using the client random and the server random. Like I told you, right? This is very important. So one PRF algorithm will be applied, and using that PRF algorithm, a secret key will be derived. And this is not transmitted because even server is aware of all these three parameters. Client is also aware of these three parameters, and they will use the same algorithm and they will compute the master secret. So you get the master secret, okay? And then from the master secret, you derive what? The client write key, server write key, etc. All this information. For us, the most important thing is client write key and server write. There are other factors also. These keys are also utilized, but we just keep in mind of client write key and server write. So once the pre-master secret key, client random, server random were actually shared with each other, okay? So we did the next phase of key derivation. So key derivation was completed. And from the key derivation, what did we derive? Client write key and server write. That's it. Now the process is very simple. Now client will say that, okay, henceforth, now till this point, we were doing the plain text conversation. Okay, it was a completely plain text. There was no encryption used here. Now from here onwards, client will say that, okay, I'm going to change the cipher spec. Now I'm going to use the encryption. Server will also say that, okay, acknowledge. Or I will also use the same. I will also use the cipher spec. No, nothing is shared here. It is this master secret, right, which will be used as the symmetric key. So basically, a client write key and server write key. So these are your symmetric keys now. That will be used for your encryption and decryption of data. Now what happens after this fourth phase? After they are ready that, okay, I will get the encrypted data and I need to decrypt it. Say now client sends its data to server. So client will do the encryption using the client write key. Okay, first point. Server knows that, okay, client has sent its data and client has actually used client write key. So it will decrypt the data using client write key. So here you can see that it is doing symmetric encryption because there is only one key now. And similarly, when server writes it, server will do its encryption using server write key, and client knows it, right? Client also is aware of the server write. So client will actually decrypt the server data using the server write. So just keep that thing in mind. So there are two different keys, one used by the server for its own encryption, and client also uses its own write key for its encryption, and the communication happens afterwards. Okay. So this is the flow of TLS 1.2. Okay. Now there was one issue with this TLS 1.2. Let's understand what is that issue. Okay. Now this whole communication which is happening, right? We are fine. The application data is encrypted. Everything is encrypted. Correct. Now, say suppose there is man in the middle attack. Now the attacker basically what it will do is it will have all this data. It will have complete network packets and all this data. But now data is in the encrypted format, and it cannot derive unless and until it knows this pre-master secret. See, this is very important, right? Because the attacker knows the random key, attacker knows the server random key, but attacker doesn't know the pre-master secret because it was encrypted using the public key of server, right? It can only know till the time it knows the private key of server. So attacker, to know the whole conversation or application data, it needs to know what the private key of the server. Just keep that thing in mind. Okay. Now what happens? Say suppose attacker keeps it for 6 months, 8 months, 1 year, the complete data, right? And then someday it was able to access this server, get its private key. Now what will happen? Now it has the complete data, right? Attacker has the complete data. Attacker has client random. Attacker has the server random. Both the things. It has the encrypted pre-master secret also. Now to decrypt it, now what attacker has done is basically now it has access to the private key of server. Now since it has the private key of server, it was able to decrypt this pre-master secret. Now it got the pre-master secret also. And once it got this pre-master secret, it will compute the master secret also. And if it computes the master secret, then obviously it can get the client write key and the server write key, and then if it knows the client write key and the server write key, it can actually decrypt the complete conversation that happened or the complete data application that was shared. So this was the drawback of TLS 1.2. So to resolve this, there was the announcement that happened in TLS 1.3. We'll look into that. So hopefully you understood the flow of TLS 1.2. Let's move to TLS 1.3. So let's start with TLS 1.3. Let's understand what is the flow and what is the change if you compare it with 1.2. Okay. So we have this normal established TCP connection establishment that takes place. Okay, this is the first phase that happened in the TLS 1.2 also. Now here things will change in the second phase, the handshake phase. Now here on the both client side and the server side, after the TCP connection is established, they both will generate a ephemeral key pair. Ephemeral means temporary. It will generate a temporary key pair. It will be a private key and the public key. So this is from on the client side, and similarly on the server side also there will be a private key and public key. It's ephemeral. It is generated by client on the client side and generated on the server on the server side. It is not steady. Now what will happen after this? There is one client hello which will take place. In this client hello, client will send only what? Public key. Client will send the client public key, and similarly server will send its server public key. Now this once this is done, now server will also send its x.509 certificate. So we have this certificate, server certificate. Now some verification will happen, and once verification is happened, then we know that okay. So why this verification is required in this case? See, we are not expecting any public key in this case. It is just used for the authentication purpose. That's it. It is just used for authentication purpose. Just keep that in mind. It is just to verify that the server which has sent the public key, right, whether it's a valid server or not. Like say I am accessing HTTPS www.sdfcbank.in, right? If I'm doing that, then I should validate it, right? The certificate sent by that particular bank, it's a valid certificate or not. It could be, if it is invalid, then I will end the connection there itself. So this verification is for the authentication purpose. Now your second phase is completed. Now comes the important part of key derivation. Now your things will change when you compare it with the TLS 1.2. Now what will happen? Again, this is local. Nothing is sent over the network. So what does client have, and what does the server have from the client? Only public key. Just keep that in mind, which is ephemeral. Okay, this public key is also ephemeral. It is only till this session is active. Once this session is not active or it's done, the next new session will have a new private key and the public key. Just keep that thing in mind. Okay. So in the next session, if you try to use the previous session's private key or the public key, it will not work. It will not work. The decryption will not happen. Just keep that thing in mind. Now in this particular session, which is going on, which is active, what will happen? Since I have shared the public key and public key, the client has shared its own public key to server, and server has sent its own public key to client. Using this ECDHE, so now both the client and the server will compute the shared secret. Okay. Or basically this is not shared actually, but because using this algorithm, what will happen, it will derive the same secret key. So that's how it is shared. Okay, that's how it is shared. It is not shared over the network, but since what was the public key of server? Okay, so as you can see, the public key of server was B on the client side, and what was the client's private key? It was A. Okay. So using ECDHE, what it will do is it will generate this A into B something. It will create one secret code. Similarly, on the server side, it will have what the client's public key and its own private key. Using that, it will, when it generates the secret code. So this algorithm works in that way that it is going to create the same secret code. Okay, it is going to create the same secret code. Just keep that thing in mind. Okay, how that internally works, it's a different thing. It's a mathematical formula. We will not deep dive into that thing, but just keep that thing in mind that using the public key of the server on the client side and the private key of the client, it is able to derive the secret code. And similarly on the server side, using the client's public key and the server's private key, it was able to derive that same secret code. There is no transmission. Just keep that thing in mind. There is no transmission between client and the server. The secret code is never transferred in any form. So this is why it is very, very secure. Now next thing is, after using this, there is HTTPS algorithm. So based on this, it will derive what client write key, server write key, etc. All this information. So what we had seen in TLS 1.2. At the end, we get these symmetric keys. So once we get these symmetric keys, so when I say symmetric keys means only one key is used for encryption and decryption. And when we say asymmetric keys means there are two keys, public key and the private key, which I explained earlier also. And if you want to go deep dive into the what is asymmetric and symmetric, I have created another video for that. You can also check that video. Then we start the secure HTTPS connection. So that's how the TLS 1.3 works. So hopefully you will understand this flow and it will help you in your day-to-day work. The point is here I'm not using the public key of the server in any ways. Server certificate is only used for authentication, nothing else, just to prove that the server is valid. It's a actual just to prove the server identity, nothing else, and it is not for used for key exchange, etc. And then how do we derive the key? See, this is ephemeral key pair. Using this ephemeral key pair only, okay, this using this ephemeral key pair only, I am generating or I am creating the I am generating the secret code, and see this secret code basically it will be the same on the server side and the client side. Again, this is never transferred. This is never transferred, and then we get the symmetric keys, client right key and the server right key, and then client will send its data using the client right key, and server will send its data using the server right key. So this was about the TLS 1.3, and let's understand the difference once again between TLS 1.2 and 1.3. So here key exchange. So in this case, we were exchanging out that pre-master secret. Okay, if you remember, we were just sharing the pre-master secret in the encrypted form using the public key of the server, which was encrypted using the public key of the server. And in this case, we are just exchanging the public key, which is ephemeral. Just keep that thing in mind. It is ephemeral. In the next session, this public key is not even valid. It will not work. So that is why even if attacker will just look at that part also, even if the attacker, like in TLS 1.2, has all the data and has even the private keys also, right? So here you can see that private key is nowhere in the picture. Nowhere in the picture, and it will not work. So the decryption will never happen. Now forward secrecy. So here it is perfect forward secrecy. So see, it is even if the server's long-term private key is compromised in the future, so past TLS 1.3 sessions remain secure, like I told you, right? Because it is ephemeral key pair. In the next session, forget about the, later on in the future as well. The next session itself will not be working with the previous session's private key and the public key. So keep that thing in mind, okay? So that is why it is perfect forward secrecy. The number of round trips also has reduced in 1.3. So it is like only full handshake requires one round trip, and here it was requiring two to three round trips. And here the change cipher spec, like I told you, right? After the conversation, after the keys are generated, etc., client will send, okay, I'm just changing the cipher spec. We'll be doing the encrypted communication now. So now that is deprecated in TLS 1.3. Key derivation. So this PRF algorithm is used here. It is used as HTTPS. This algorithm is used, and server certificate usage used for authentication and key exchange. And here key exchange also happens, right, using this, because we are extracting the public key of the server from that certificate, and then we basically encrypt this pre-master secret using that public key and then send it to the server. Okay, so here it is used for both authentication, that is to authenticate the server's identity, and also to do the key exchange. And here it is only just for the authentication, not for any key exchange. No public key is expected in TLS 1.3. It is just to validate the server's identity that certificate is required. And as soon as the keys are generated, etc., is generated, immediately it will start. And so here the algorithm which is supported is RSA, and ECDHE is optional, and here only ECDHE works. Okay. So we have already discussed how server certificate is used in TLS 1.3. It is just for the server's identity, nothing else. So hopefully you would like this lecture, and if you like it, please like and subscribe my channel, and also share it with your friends, and also give me suggestions on which topic you would like to have more videos on. Thank you so much. Have a good day.